Okay. Good morning, everyone, and welcome to today's webinar, Unleashing the Power of AI in ArcGIS. So I'm your host, Camicia Blackwood, and I'm thrilled to be with you today of what promises to be an insightful and exciting session. So as GIS professionals and researchers, we stand at the forefront of a technological revolution that is reshaping the landscape of geospatial analysis. The integration of AI into ArcGIS is not just enhancing our capabilities, it's fundamentally transforming the way we process data, conduct spatial analysis, and make informed decisions. This webinar will explore how these cutting edge GeoAI tools are revolutionizing workflows, and I'm confident you'll leave here with a deeper understanding of how AI can take your work to new heights. By harnessing AI capabilities, you can expect increased productivity, better decision making, and more accurate interpretations of your geospatial data. Through the use of GeoAI, we are boosting operational efficiency, improving accuracy, and automating tasks that once consumed valuable time. Today's session will highlight how AI is unlocking hidden insights in complex data sets and providing solutions that were once unimaginable. We'll uncover a myriad of ways AI is transforming our field, whether it's through automating tedious tasks, uncovering hidden patterns, or providing predictive insights that guide decision making. We're entering an era where AI is not just an add on, it's an indispensable tool in the modern GIS toolkit. It's empowering us to tackle challenges with unprecedented precision and speed. And I'm excited for you to discover how these technologies can empower your work. To help us navigate this exciting terrain, we're joined by a true expert in the field, Nicola Simpson Lake, Senior Account Manager for Spatial Innovation. Nicola has years of experience working with organizations across industries and implementing ArcGIS and GeoAI solutions. And she's here to share her insights into how AI is transforming geospatial workflows. So, whether you're new to AI or already integrating it into your work, there's something here for everyone. I encourage you to engage with the content and take full advantage of the wealth of knowledge we have for you. You can make note of any questions you may have, and I'm asking you to direct them to the end of this session so we can move more smoothly. You can also submit your questions using the Q&A feature that we have here on Zoom. So without further ado, let's dive in. Nicola?
Thank you for the introduction, Camicia. Good morning, everyone, and welcome to an exciting journey into the world of artificial intelligence and its transformative impact on ArcGIS. As introduced, my name is Nicola, and I will be your presenter. So for our agenda this morning, we will first look at what is AI and how AI technologies can be seamlessly integrated into your ArcGIS workflows. Then we'll look at how users can automate data processing tasks. Next, we'll explore how AI capabilities in ArcGIS can revolutionize spatial analysis process. Then we'll have a demo illustrating how AI-powered insight can support better decision-making. After which, we will discuss how AI enhances data accuracy through advanced pattern recognition and predictive analytics. And then lastly, we will discuss how AI algorithms can automate repetitive tasks, saving time and resources. And after which, we hope to hear from you. Before we discuss how AI-powered insights can increase efficiency and accuracy and support better decision-making, let's briefly explain what AI and machine learning are. So artificial intelligence is the idea of achieving human-level intelligence. Machine learning is a field within AI that's about learning from data to derive rules and extract patterns, while deep learning is one type of machine learning that is becoming very good at extracting patterns from highly unstructured data like voice, image, and text. In almost 90% of cases, when people say AI, they really mean machine learning. So geospatial artificial intelligence involves, excuse me, integrating artificial intelligence with geospatial data, science, and technology to enhance the comprehension of business opportunities, environmental effects, and operational risk in the real world. Organizations are modernizing their operations to perform efficiently on a large scale by utilizing automated data creation and user-friendly spatial tools and algorithms. AI integration in ArcGIS enhances geospatial analysis through the application of machine learning, deep learning, and GeoAI technologies. Now, these tools will enable you, the users, to automate repetitive tasks, extract features from spatial data, and perform advanced analysis more efficiently. So these innovations enable more efficient data processing and insightful analysis across various applications. So you can find machine learning capabilities in many ArcGIS products today. For example, ArcGIS API for Python includes ArcGIS.learn, which is a deep learning module. And there are also machine learning tools in ArcGIS Pro, as well as other capabilities in ArcGIS Enterprise, ArcGIS Insights, ArcGIS Notebooks, and more. So our flagship software, ArcGIS Pro, offers capabilities for classification of remotely sensed data and utilize pre-trained models for text and image analysis. So what can machine learning do? You can find machine learning capabilities in many ArcGIS products today. For example, excuse me. All right, so what can machine learning do? GeoAI accelerate the time to situational awareness, and this means it allows you to monitor and analyze events, assets, and entities from sensors and sources such as video to enable quicker response time and proactive decisions. Now, there are 5 major patterns in machine learning. The first one is about extracting features from imagery and LiDAR. This example include detecting building footprints from satellite imagery and detecting assets from LiDAR. The second pattern is about making predictions, like predicting disease propagation or vehicle crash risk or water main failures. In short, predicting geospatial events. The third pattern involves finding patterns and clusters in data that are challenging to extract visually. The fourth pattern on screen helps you to detect anomalies and outliers. And the fifth pattern is about extracting insights from unstructured texts like crime reports and bringing this data to ArcGIS to do spatial analysis. Now, using deep learning, which is a type of machine learning, as mentioned, you can extract geospatial data, saving time by automating the extraction, classification, and detection of information from data such as imagery, video, point clouds, and text. AI allows you to make predictions by analyzing past data and real-time information. You can accurately predict scenarios for risk growth or optimizing operations. It also allows you to search for patterns hidden in large amounts of data or imagery and find the right places to take action. So the combination of AI with GIS facilitates deeper insights and improved decision-making by leveraging vast amount of spatial data. This integration supports various applications across industries, making it a powerful asset for GIS professionals. Now, before we discuss the machine learning capabilities in ArcGIS, let's quickly explore what a typical machine learning lifecycle looks like. So it first starts with data preparation, and we want to prepare the data so it's ready for machine learning workflows. And this includes bringing data from multiple sources, data wrangling, dealing with missing data, geo-enrichment, data labeling, and other things. The second is about training a model that is meant to perform a specific function, whether it's predicting something or finding patterns or detecting objects. We can train different kind of models, supervised or unsupervised. After that, there is inference step, which is the process of using the model to achieve some result. It doesn't stop there. We typically want to derive insights by doing analysis on top of the model, like suitability analysis. Finally, we want to share those results with others. So we build information products like maps, apps, and dashboards. So the clip on screen is an example of how AI and location is used to identify areas where vegetation is threatening power lines, saving time and avoiding costly labor-intensive inspections. Now, for those of us who have been affected by power outage because of overgrown vegetation touching power lines, this model is addressing that operational risk and promoting operational efficiency mentioned earlier. So here we are promoting safety and preventing disruption through the use of AI. Now there will be a demonstration later on this model and how it was built. Our next topic is AI-powered data processing. AI algorithms have revolutionized data processing in ArcGIS, transforming raw geospatial data into actionable insights with unprecedented speed and accuracy. These sophisticated algorithms excel in handling massive data sets, automating complex data cleaning procedures, and seamlessly integrating information from diverse sources. So one of the most significant benefits of AI in data processing is its ability to identify and correct errors automatically. Machine learning models can detect anomalies, fill in missing data, and even reconcile conflicting information from different sources. This not only saves countless of hours of manual labor, but also significantly reduces the risk of human error in data preparation. Now, how do you utilize AI algorithms for data processing? Machine learning capabilities in ArcGIS fall into two major categories. The first category includes tools that can help you build machine learning workflows, whether you're interested in doing parts of that workflow or all of it. Some of these tools are codeless, where you don't need to write code to use it. Examples include doing feature extraction using the ArcGIS Image Analyst extension with ArcGIS Pro, or building predictive models using the tools in Pro with ArcGIS Spatial Analyst, or extracting features from LiDAR using the ArcGIS 3D Analyst extension with ArcGIS Pro. So the first category also includes tools delivered as part of code-first experience. Now, this includes the ArcGIS API for Python, where you can prepare data, train models, and use them using Python code. You can do the same thing in ArcGIS notebooks. So the second category of products The second category of products and capabilities that are AI infused. Here, AI is already inside the product, but you don't really know about it. An example is the tree extraction capability in 3D base map solutions. It uses a pre-trained model to extract trees, but you don't need to train the model from scratch or load it. The tool is designed to do everything for you, and all you see are the results. Now, what are some of the benefits of AI in automation? AI significantly enhances the efficiency of data and of data cleaning, integration, and analysis process by automating repetitive tasks as stated, which saves time and reduces human error. It accelerates data preparation and visualization, allowing analysts to focus on more complex decision-making tasks. Additionally, AI can manage large data sets effectively, ensuring accuracy and consistency in data handling. By utilizing machine learning algorithms, AI can identify patterns and anomalies, improving data quality. The integration of AI technologies leads to faster insight and more informed business strategies. Now let's talk about those tools that can help you build machine learning workflows. From your classification to clustering to prediction, ArcGIS has a series of tools that already use machine learning for their algorithm. For example, on the classification, we have your support vector machine classifier that is used to classify in previous surfaces from imagery. For clustering, you can use the space-time pattern mining tools to identify the emerging and fading hotspots in crash data. And for prediction, you can use the geographically weighted regression tool to build predictive models that would predict things like disease propagation. So it's worth mentioning that some of these tools use spatial machine learning, which means that the way the algorithm works is inherently spatial. In many cases, that makes these tools generally more suitable compared to traditional machine learning algorithms. Enhancing spatial analysis with AI. AI tools dramatically improve spatial analysis capabilities in ArcGIS, enable GIS professionals to uncover deeper insights and make more informed decisions. These advanced algorithms can process and analyze spatial relationships at a scale and speed that were previously unattainable, opening up new possibilities for understanding complex geographic information. One of the key advantages of AI-driven spatial analysis is its ability to identify patterns and correlations that might be invisible to human eye. Machine learning algorithms can sift through vast amounts of geospatial data, recognizing suitable trends and relationships that can inform everything from urban planning to environmental conservation. So for predictive modeling, machine learning models can forecast future spatial trends based on historical data, enabling proactive decision-making in areas like disaster management and resource allocation. For pattern recognition, our AI algorithms excel at identifying complex spatial patterns such as urban growth trends or wildlife migration routes, providing valuable insights for planners and researchers. And for network analysts, AI allows you to optimize routes and resource distribution in complex systems, one of which is utility grids. And earlier we looked at a clip for our model, identify vegetation affecting power line. And as mentioned, we will have a demo on this. AI-driven spatial analysis techniques in ArcGIS have revolutionized the way we interpret and utilize geospatial data. These advanced methods go beyond traditional GIS analysis, incorporating machine learning and deep learning algorithms to extract more nuanced insight from complex data sets. By leveraging these AI-powered techniques, AI professionals can make more accurate decisions. And this is something that we'll be driving throughout the presentation. It will identify suitable patterns and generate actionable intelligence for a wide range of applications. So one particular powerful technique is the use of convolutional neural networks for image classification and object detection in satellite imagery. And this allows for rapid and accurate mapping of land use changes, urban development, and even the impact of natural disasters. Another innovative approach is the application of graph neural networks. And this is to analyze spatial networks, enabling more sophisticated model of transportation system, social networks, and ecological relationships. So now we'll look at some of the workflows. And our first workflow is predictive analytics. So using predictive analytics, you can build predictive models that predict asthma rates, house pricing, sea habitats, and more. You can also build models that forecast time series data like forecasting sales. These tools can also help you beyond predicting an event. For example, the variable importance tool can help you understand the most impactful factors that influence the model's predictions. Predictive tools can also help you understand the relationship between variables and the statistic correlation between them. You can use this information when building the model to eliminate features or variables that are already highly correlated with each other, so you can streamline the model. A next workflow is pattern mining and clustering. So pattern mining and clustering tools help you identify interesting groupings in the data that might not be that obvious at first glance. You can use the space-time pattern mining tools to understand the emerging and fading hotspots of crash data to understand where policies are effective and where it's not. You can use density-based clustering with the same data to understand the riskiest intersections that we need to take care of. And we can use the spatially constrained multivariate clustering to find spatially contiguous clusters for animal territories. So our next workflow is anomaly detection. And machine learning is great for finding anomalies and outliers. And we have tools in ArcGIS that can help with anomaly detection. For example, the time series forecasting tool can be used to spot temporal outlines. This can help us identify abnormal spikes in machine sensor reading across time, which could be used as a proxy for predicting potential sensor failures. That's just one example where temporal outliers are useful. The spatial outlier detection tool can detect outliers from a spatial perspective. For example, an organization maintains air quality monitoring stations that are used for air quality surface interpolation. That organization can use this tool to identify the most isolated monitors so they can see where supplemental data gathering is necessary. Other tools can spot abnormalities from both space and time perspective. like the local outlier analysis tool in space-time pattern mining toolbox. These tools can help you spot time periods with unexpectedly high rates of disease outbreak across a study area. Now, the imagery deep learning tools enable end-to-end workflows. They can help with managing, storing, and pre-processing imagery. They can also help with data labeling, which is needed if you want to train deep learning modules for object detection or pixel classification. You can also export training data in the format that's required to train models. For more training, these tools provide, for model training, these tools provide different network architectures for different purposes, like edge detection of classification, instance segmentation, and more. You can then save models to be used in Pro, Enterprise, and you can publish them in items on your portal. So the advantage of doing this in ArcGIS is that your work does not stop here. You can use different spatial analytics on top of the outcome from the model to derive insights and answer bigger questions. And then you can use maps, apps, and dashboards to disseminate the information and share it with others. This could be done with a wide range of data types like aerial imagery, satellite, radar, LiDAR, motion imagery, bathymetry, and more. Our next workflow is our pre-trained models. And the ready-to-use models on the ArcGIS Living Atlas can save a lot of time. So instead of preparing training data and training models from scratch, you can use these ready-to-use models for your workflows. They are well trained for different data sets or scenarios, but you can also retrain the models with local data if you need to increase the accuracy in your particular workflow. So the ArcGIS Living Atlas has lots of models for common workflows, like identifying building footprints, road segments, land cover, human settlements, swimming pools, solar panels, and more. You can use these models in Pro, ArcGIS Online, or Enterprise. So now let's look at some examples of workflows that benefit from using the imagery deep learning tools. Here we see examples for projects that Esri have been working on, like detecting damaged structures and roads for public safety scenarios. This could be helpful when responding to disasters to understand the impact and extent of damage and prioritize rescue operations. We can see the automation of the map. You can also see scenarios like crop detection and health assessment for crops, like assessing the health of palm trees by combining deep learning with spatial analytics. For the oil and gas industry, we can see scenarios like pipeline encroachment identification. For departments of transportation and local government, we can see scenarios like road crack detection. So these tools can also work with ArcGIS FMV to track objects like vehicles. So another workflow is feature extraction from LiDAR. And the first image illustrates the extraction of features from LiDAR using deep learning point cloud capabilities. Examples include extracting utility poles and lines. Utilities can also use these capabilities to detect encroachment and trees, helping with vegetation management. Rail companies can extract assets to make sure they always have the most accurate and updated maps, complete with the locations and even condition of assets like crossings and mileposts. State and local government can classify buildings and street furniture as well. And the ArcGIS Living Atlas has several ready-to-use models for extracting features from LiDAR, including trees and power lines. The next workflow is ArcGIS Learn. Now, with these workflows, while these workflows are possible with codeless tools, as mentioned earlier, like ArcGIS Pro and its extension, they can also be performed through a code-first experience using ArcGIS.Learn, which is the deep learning module of the ArcGIS API for Python. ArcGIS Learn helps you build machine learning workflows easily through few lines of code in a consistent manner. This saves you from needing to install and configure different deep learning frameworks for your specific use case. You can use ArcGIS.Learn in different Python IDEs like ArcGIS Notebooks, your own Jupyter Notebook, or PyCharm, and more. Next, we have extract insights from unstructured text. Now, almost 80% of the world data is unstructured. A big portion of that is available in the form of unstructured text. This can include reports, social media, online forums, customer service logs, and more. The ArcGIS API for Python provides different text analytic and natural language processing capabilities through the ArcGIS.Learn module for entity extraction, text classification, translation, and more. You can use the name entity recognition capability to extract entities like organization, people, dates, and locations from text. You can then bring the output back to ArcGIS Pro to perform spatial analysis. And our last workflow is ArcGIS Notebooks. Now, ArcGIS Notebooks can facilitate machine learning workflows because it brings the open source data science ecosystem together with ArcGIS. ArcGIS Notebooks includes more than 300 Python data science libraries, all pre-configured to work seamlessly with ArcGIS data stores, analytic engines, such as ArcGIS Image Server and ArcGIS Geo Analytics Server, and spatial analytics tools. You can use ArcGIS Notebooks in ArcGIS Pro, ArcGIS Enterprise, and ArcGIS Online. It also comes with a gallery of sample notebooks for different types of spatial analytics, including machine learning and deep learning. So we've reached the first, or demo for the morning. And for this demo, we'll be looking at vegetation encroachment using LiDAR. Now, using a newly added tool in ArcGIS Pro and pre-train deep learning models from the Living Atlas, we can solve a problem like vegetation encroachment in an automated manner. So this is an important use case for utility companies around the world. Vegetation management is very crucial as uncontrolled vegetation encroachment can very easily lead to fires, power outages during a storm, etc. So the demo classifies points representing the ground, buildings, vegetation, distribution wires, and poles using Esri's pre-trained deep learning models and geoprocessing tools in ArcGIS Pro. Then advanced GIS analysts with Model Builder is used to identify locations with vegetation encroachments that will need trimming or management. So the demo will take you through each step of the data processing, showing each geoprocessing tool and parameters for each step discussed, as well as the model builders. And the tools, just to note, the tools were previously run, so I will not be running them during this demo. You will, however, see the results of each tool discussed. Now, when it comes to electoral power distribution via transmission or distribution wires, a lot of maintenance costs for these power line networks are due to vegetation management around the power lines. Vegetation management is very crucial as uncontrolled vegetation encroachments can easily lead to problems, as stated, such as fires and power outages during storms. Identifying the maintenance spots that need trimming or vegetation management is a time-consuming process. Many times a manual survey is done or the survey is partially assisted via remote sensing data. Companies can spend millions on vegetation encroachment management. Now, with the recent advancement in deep learning for remotely sensed data, this problem can be solved much faster and at scale. In this demo, we will perform vegetation encroachment analysis on 3D data with the help of deep learning and advanced GIS tools. So we're using classified airborne LiDAR data over a small area located in Australia using geoprocessing tools and deep learning packages. We will classify the raw LiDAR points for ground, buildings, utility wires, and poles and trees. We then convert the LiDAR points to vector data, generate 3D volumes for trees and wires, then find the intersection of those volumes. So let's start our demo.
For our first step, we will use a geoprocessing tool to classify the ground points. Now, as stated, this model was previously run, so all our tools used are stored in our history. So we'll go ahead and open or classify LAS ground tool from history. We will then check the parameters to ensure all information are set correctly. Now, in the interest of time, we have run all the tools previously as stated. So for this demo, we will only be displaying the results for each tool shown. So we'll go ahead and display our ground points, and this was achieved using our geoprocessing tool. After ground points are classified, building points are classified using the Classify LAS building tool. Now we'll once again go to history and open the Classify LAS building tool. We will then check the parameters to ensure all information are set, and we want to ensure that both above and below roof points are also classified as the building class. Once this is completed, we will then display the building points, and this was generated again using our geoprocessing tool. A tool introduced at ArcGIS Pro 2.8 is used for inferencing using the deep learning models. This is our classify point cloud using train model found in our 3D analyst toolbox. So we'll go ahead and search for this tool in our geoprocessing tools. We'll first run this tool using the pre-trained model that classifies distribution wires and poles. We'll first add step 3, and then we'll add our power lines classified layer. Now, because this model was previously run, we have the result for step 3. So this process preserved the existing classified for ground and building. So looking at the parameters in the tools, we see class clouds 14 and 15 selected. Now, please note, in a normal workflow, you would not already have 14 and 15. However, as stated, because the model was previously run, we were able to obtain this from the classified power line layer. So we'll go ahead and add the other codes that we would like to preserve for this process. So once this is completed, we will then display our power lines, and this was achieved using deep learning. So now we'll run the tool using another pre-trained model to classify trees. We want to identify high vegetation areas. So while preserving all the existing classes, we will now include the wires and poles. So we'll add step 4 as this was previously run, and we will also add our 3-point layer. Now, similar to the previous step where we saw 14 and 15 class cloud preserved, here class 5 is also preserved. We will also go ahead and add existing codes that we would like to preserve for this process. Now, once this is complete, we'll then display our high vegetation area. We'll then go to bookmark to give you a more closer look at this area, showing our trees, power lines, and poles. So now all the points representing the objects of interest are classified in the test data. After visualization of results, advanced GIS analysis is performed to identify locations of vegetation encroachments. The classified point cloud is first converted to vector data. Then, with the help of various geoprocessing tools, vegetation encroachment spots are identified. A model builder workflow is created to process the data. We limit our scope to the points that are nearby power lines for post-processing. We find the volume of these two objects, trees and power lines. Then their intersecting 3D volumes give us not only an idea about the vegetation encroachment, but also its severity based on the volume capacity of the 3D sections. Intersects. So we'll go to bookmark and get a closer look at the volumes of wires and nearby trees. We'll then turn off the main workflow and turn on our model builder. We'll then go to bookmark again to show the intersecting volumes. And then we'll turn on the intersection 3D. Those are intersections. So we'll then go to the bookmark and identify the maintenance locations. So the last step of the model was to create point features from the intersections. And we made a copy of this final point layer and symbolized the points with large question marks. So these are the areas that will need to be visited for maintenance. So this demo has walked us through the workflow for vegetation encroachment analysis using Esri pre-trained models. So covering both the deep learning and advanced GIS workflows. So the GIS approach used is based on post-processing of vector data. Thank you. For our first step, we will use a geoprocessing. For our first step,
All right, so now that we were able to see a workflow using some of the tools and workflows discussed earlier, our next area we'll be looking at is accuracy improvement through AI. Now, the integration of AI into ArcGIS has led to remarkable improvements in the accuracy of mapping and geospatial data interpretation. AI algorithms, particularly deep learning models, have shown an exceptional ability to extract precise information from various data sources, including satellite imagery, LiDAR data, and aerial photographs. This enhanced accuracy is transforming the way we create maps, monitor changes in the environment, and make decisions based on spatial data. So one of the most significant advancements is in the field of feature extraction and classification. AI models can now identify and classify objects in imagery with human-like accuracy, but at a much larger scale and faster pace. This has revolutionized tasks such as land cover mapping, urban feature detection, and even the identification of individual tree species in forestry applications. So for image classification, AI models achieve up to 90% accuracy in land cover classification using surpassing traditional methods by a significant margin. Next, we have feature extraction detection. And using deep learning algorithms, you can delineate boundaries of geographic features with sub-pixel accuracy, which improve the precision of vector data extraction. Then we have our change detection, and this allows you to identify minute differences in multitemporal satellite imagery. Next, we have automated quality control, and this is an API-powered system which allows you to automatically detect and flag potential errors in geospatial data set, ensuring higher data quality and reliability. We also have multi-source data integration, which is a machine learning technique which enable more accurate fusion of data from multiple sources, creating more comprehensive and precise geospatial products. All right, so now we'll have a look at some case studies. So Real-world application of AI in ArcGIS have demonstrated significant improvements in accuracy across various domains. These case studies illustrate the tangible benefits of integrating AI into geospatial workflows, showcasing how enhanced accuracy leads to better decision making and more effective resource management. So one notable example comes from urban planning, where AI-powered analysis of high-resolution satellite imagery has enabled the creation of more accurate and up-to-date land use maps. In a major metropolitan area, the use of deep learning algorithms for feature extraction and classification resulted in a 22% improvement in mapping accuracy compared to traditional methods. This enhanced accuracy allowed city planners to make more informed decisions about zoning, infrastructure development, and green space allocation. As a result of AI-based inventory showing a higher accuracy in addition in predicting forest attributes compared to traditional methods, we see a 22% improvement in mapping accuracy. Likewise, AI-based flood risk assessment demonstrated higher accuracy in predicting flood-prone areas and estimating flood depths compared to traditional methods, which led to an increased accuracy of 22%. And then finally, we have AI-based agriculture yield prediction models demonstrating higher accuracy in forecasting crop yields compared to traditional methods, especially in complex and dynamic agricultural systems. This area has the highest increase of 23% improvement in mapping accuracy. So our final area for this morning is efficiency boost with AI automation. AI automation has revolutionized workflows in ArcGIS, dramatically increasing efficiency and productivity for GIS professionals. By automating repetitive and time-consuming tasks, AI allows analysts to focus on higher level problem solving and decision-making process. This shift not only accelerates project timelines, but also enable organizations to tackle more complex geospatial challenges with existing resources. So modern GIS brings all this data together. It also contains many powerful location analytical tools to increase your overall business intelligence. These analytic applications and capabilities assist with many business workflows through insights in optimizing work plans, such as the processing of imagery and drones information, including flight planning and LiDAR. We also have one of the most impactful areas of AI automation, which is in data processing and quality control. Machine learning algorithms can rapidly clean, validate, and standardize large volumes of geospatial data, a process that would traditionally take days or even weeks to complete manually. This automation ensures that analysts are working with high quality, consistent data from the outset, reducing errors and improving the reliability of subsequent analysis. Now, time-saving benefits of AI. The integration of AI into GIS workflows has resulted in substantial time savings across various aspects of geospatial analysis. These efficiencies not only accelerate project completion, but also allow organizations to take on more ambitious and complex geospatial challenges. By automating time-consuming tasks and streamlining workflows, GIS professionals can focus on high-value activities that require more human expertise and creativity. One of the most significant time-saving benefit comes from AI-powered data processing and analysis. Tasks that once required days of manual work can now be completed in hours or even minutes. For example, AI algorithms can automatically classify land cover types in satellite imagery, a process that traditionally required extensive manual digitization and interpretation. This automation not only saves time, but also ensures consistency across large data sets, reducing the need for time-consuming quality checks and revisions. Now let's look at some of the benefits of time saving where AI is concerned. So time saving, this is the AI automation can reduce data processing time by up to 80%, allowing GIS professionals to focus on analysis and interpretation rather than data preparation. Task automation allows our professionals to do routine tasks like feature extraction, image classification, and map updates that can be fully automated, freeing up human resources for more complex objects. For scalability, AI-powered workflows can easily scale and handle massive data sets, enabling organizations to process and analyze geospatial data at unprecedented scales. And for innovation, by automating routine tasks, GIS professionals have more time to explore innovative applications and develop new methodologies, driving the field forward. Now, on screen, it is showing how much time it would take for a GIS professional to complete image classification or feature extraction or change detection. Now, compared to how much time it would take using AI. So here we're seeing for the amount of time it would save a analyst to do image classification using the traditional method, using AI, it would save you around 93.7%, which feature extraction, you would save around 93.7%. And with change detection, 94%. So AI increase the efficiency and the time it would take for you to perform a task. All right. So we've discussed how AI and ArcGIS can revolutionize the market, and we've looked at some of the tools and workflows that can be used in different industries. Now we will have a look at the success stories. And these are some of the success stories for customers using AI capabilities to solve their problems. GIS professionals from Kuwait uses the deep learning tools to automate map production workflows and save time. They now detect building footprints and road segments across the country with high accuracy and perform this work 17 times faster than they used to. The state of Bavaria in Germany uses notebooks with deep learning to forecast road condition and predict the deterioration of road segments, aiding with road maintenance. An Australian utility leveraged deep learning tools with LiDAR to automate asset extraction from a 10 billion point cloud, saving them 50,000 man hours. USAA automated damage claims processing by detecting damaged buildings from aerial imagery taken after fires. And finally, we have Nob Hill Water Association, who uses machine learning with ArcGIS to predict water main failures. So these are just some of the success stories, and their links will be made available to you. So you can go ahead and have a look at them. All right, so now we've come to the end of our presentation, and the future of AI in ArcGIS is poised to revolutionize geographic information systems through enhanced data analysis and decision-making capabilities. AI technologies will enable more accurate predictive modeling, automate routine tasks, and improve the efficiency of spatial data processing. Additionally, integrated machine learning algorithms will facilitate advanced pattern recognition and anomaly detection in geographic datasets. As AI continues to evolve, it will empower you, the users, to derive deeper insights from your data, ultimately transforming how organizations approach spatial analysis and planning. So, the integration of AI will also foster innovation in urban planning, environmental monitoring, and disaster response, making GIS tools more accessible and impactful across various sectors. So, as the users, what should you be doing? We want you to continue learning, stay updated with AI advancements in GIS through training and workshops. We want you to collaborate with AI, embrace AI as a powerful tool to augment your GIS expertise. And finally, we want you to innovate, explore new applications of AI in GIS to solve complex spatial problems. And we've reached the end of our presentation. Thank you for joining us this morning.
Okay, thank you so much, Nicola, and thank you all for joining us today for Unleashing the Power of AI in ArcGIS. I hope you found today's session insightful and inspiring. A special thank you to Nicola again for her expert guidance and for sharing her extensive knowledge on how AI is revolutionizing geospatial workflows. As we've seen today, the integration of AI into ArcGIS offers incredible opportunities to streamline processes, automate tasks, and enhance spatial analysis, unlocking a whole new level of efficiency and accuracy in your GIS projects. Whether you're looking to incorporate machine learning, improve decision making, or simply make your workflows more automated, the potential for transformation is enormous. I encourage you to take the insights and practical tips Nicola shared today and apply them to your own work. There's no better time than now to explore how AI can help you overcome challenges and achieve better results in your geospatial projects. If you have any follow-up questions or would like to continue this conversation, please don't hesitate to reach out. We're here to support you as you explore the exciting world of GeoAI in ArcGIS. Thank you again for your time, and we hope to see you in the future for our future webinars. So stay tuned for more opportunities to learn and grow in your GIS journey. Have a great rest of your day.